Hey folks, welcome back to our office hours of February this month with your host, Laura Tchaikovsky, based over here in the UK, and our developer advocate, Joe, who's based over in Canada. We're looking forward to getting to talk to you today to learn more about mastering Dragonfly, the Kubernetes operator. So I'm going to hand over to Joe to go talk us through the agenda, and we'll take it from there. Over to you, Joe.
All right, thank you, Laura. So yeah, can you guys see my screen okay? I just started
Perfect.
sharing. Awesome. Right, so in today's community office hour, first off, welcome all the community members. So in this office hours session, we're gonna talk about Kubernetes operator for Dragonfly. So yeah, without any further ado, let's get started.
You prepared a little agenda for us to cover through today.
Yes. So for today, we're gonna have a few things to talk about. We're gonna have first off a community update from Laura. We're gonna see like what happened recently and what's gonna happen next. And then I'm gonna do a very brief introduction to Dragonfly in case some of the folks don't know what the project is. And another introduction to Kubernetes and the operator pattern, right? And then we're going to go through the overview of our Dragonfly operator features. We're going to do a hands-on demo, and we're going to have a very brief introduction to Dragonfly Cloud if you're interested as well. And we're going to take questions from the community afterwards. Cool. So first off, let's head to the community update. Over to you, Laura.
Yeah. Thank you. So I want to give a big shout out to Michael Premu, and I'm hoping I'm pronouncing that correctly. Thank you very much to Michael, our community member, who submitted his first PR. So thank you for that. And everybody is more than welcome to submit PRs. He discovered a server flag compatibility issue. So he took the time to go to GitHub to report the issue. And then he engaged with our developers and our engineers inside to verify that actually was a compatibility issue. And he also provided the PR to go with it. And it was perfect, and we accepted it. So we want to have more of that if possible. So we welcome all PRs. So if ever you're stuck, you can head on to dragonflydb.io and head on to install, download it. And if you get started and you find any issues, please let us know. You can either file the GitHub issue directly, or if you want to pop into our Discord channel and provide some context or some feedback about it, we'd love either way. So thank you very much. But a big shout out to Michael. So we want to see more of this coming forward next month. Thank you. Next slide. So here's a new program that I've just launched last week. We want to hear from our community members themselves. How have you been getting on with Dragonfly? Any topics that you want to cover, and share those stories. And I've given a selection of potential topics that you may be interested in writing about. So everything from advanced database management techniques all the way to integration guides. We've done some recent ones that Joe has published, and Costas, one of our engineers, on the BullMQ and Sidekick. So we'd love to know any other potential other integrations that are out there that want to use Dragonfly. And if you take the time to write that blog post, we want to say thank you very much for starters. And to show the value of that and to the value of our community members, we're going to pay you $300 per blog post that's published because it is valuable time that you're giving up to write content. And each of those blog posts, we're going to publish them on our blog, and we're also going to get them syndicated on the likes of DZone and on Dev too, and share that with the wider community so they have a wider reach than just myself and Joe making them. If you have any questions, head on to our blog page, which basically gives the entire spec of introducing the Dragonfly full program. It shows you how to submit it. And any questions, you can always just contact me at any given time, either on the Discord channel, Tchaikovsky, Laura, or emailing me, laura@dragonflydb.io. I'm open to any questions. Thank you. Next slide, please. So here's our new sneak peek into our competition that opens up tomorrow. It's something new that we just thought would be a bit of fun and have a bit of a challenge about. It's an ASCII challenge, right? So when you install Dragonfly, you don't really get anything kind of fun to generate. So we thought we'd actually change that and give you, the community, a chance to present to us something different. So it's going to be an install image makeover challenge. In ASCII art, when you install Dragonfly, and again, all the details become available tomorrow in our blog post, including the character length, how to submit it. But just to give you a sneak peek of what's coming in our community, you will get credit on the installation. So for future releases, it'll get credited to you. So thank you for that. And maybe this is something that we do going forward for our different GAs. It's something a bit of fun that we can thank our community who are very creative. I'm looking forward to seeing the different types of ASCII art that is submitted to us. I'm looking forward to the creativity. And then hopefully, over the next 4 to 5 weeks, we get submissions. And at the end of that, we'll open up to the community to vote. So you, the community, get to choose what you see when you install Dragonfly. But the blog post will go live tomorrow. So by the time you see this, you may be live. And if you have any questions, again, just feel free to contact me or Joe. We're happy to help you. Thank you very much. That's the community update from my side of things. Back over to you, Joe.
Cool. Thank you so much, Laura. That's very exciting. Yeah, please, developers, DevOps, engineers, and architects, don't be shy and join our activities. Right. So let's continue. So we're gonna talk about the Dragonfly Kubernetes operator today. Before that, let me give please a very brief introduction to what Dragonfly is. Right. So Dragonfly is an open source community-driven project. It's a drop-in replacement of Redis. We have like a brand new multi-threaded shared nothing architecture built from ground up. So we want to deliver like more performance. We want to saturate the hardware and squeeze every bit out of it. So as of February, as of today, we have 22.3K stars on GitHub. Thank you so much again, all the community members, for supporting us. Right. So Dragonfly, it's designed to fully utilize the modern hardware. Right. So if you have noticed our newest blog on the AWS C7GN 16X large instance, which is a AWS instance that's been released last year around June, based on their Graviton 3E CPUs. So it's a relatively new, fairly new instance. So on that, we're able to achieve 6.43 million operations per second. Right? So that's about 60% increase from like our previous rounds of benchmarks, which was 4 million on C6 Gen, right? And one Dragonfly. So yeah, I think that's amazing. That's we have more details in the blog post, but overall, we don't have to like tune much in terms of the existing code base, right? So the architecture itself of Dragonfly, it adapts to like hardware. It advances with hardware together. And in the meantime, a single Dragonfly instance is able to support 1 TB of in-memory data on one single instance. So that's to me, that's quite impressive as an in-memory disk store as well. Dragonfly is also 100% compatible with Redis and Memcached in terms of the wire protocol. At the moment, we have 240 plus Redis commands supported, and we also support all Memcached commands. Right? So yeah, as I mentioned earlier, like Dragonfly is designed to be very hardware effective. So based on our tests, we're able to get up to 50% or even more cost savings on hardware. So yeah, it basically just utilizes the memory and CPU better. We have primary replica model for high availability, and we also have a very active community on GitHub, Discord. Yeah, please join us, find us on these platforms, and yeah, it will be very excited to see you guys there. Cool.
So
and
we just have a question here. Sorry, we've got a question here from Will. Will has raised his hand. Will, if you want to like ask a question, if you just message it here, I'll repeat it over to Joe. He probably just can't see the hand being raised on the call. Give him a second to type. He might just want to type it, and then I can message it over to you or call it out to you.
Sure.
Okay. Okay, hasn't just responded just yet. If Will does, Will, just let me know and we'll pass it over to Joe. Thanks.
Sure. Sounds good. So yeah, and Kubernetes, on the other hand, I guess like we're in a cloud era now, right? So Kubernetes is a very important tool, for cloud, and it is for container orchestration, right? So at its core, it is designed originally for stateless applications, right? It's designed with a control loop mechanism where like it is like superb managing stateless applications, right? So these applications, like for instance, one of my microservice instance, right? So it's stateless. They are identical to each other, and they keep they don't keep, or they keep like very minimum internal state, right? So they can be replaced very easily, right? So in a Kubernetes environment, this means that the control loop, it will continuously observe your desired state of the cluster, depending on your configuration, and then apply, the logical changes to the actual state. So for stateless applications, it's a lot easier because all the instances or all the pods are replaceable, right? So it provides so that's about it. Kubernetes provides the ability to scale your services up or down, or handling rolling updates, or maybe like version upgrades, and also manages health checks for your pods, right? So yeah, that's underneath. Very briefly how the Kubernetes control loop works. As for databases or data stores, right? So it's a little bit harder because these applications are indeed stateful, right? So they're not stateless. We want to keep the data somewhere, either in memory, maybe on disk. Maybe we keep backup snapshots as well, right? So they are naturally stateful, right? So data stores. That's why data stores are normally managed by Kubernetes using stateful sets. So stateful sets, they have like pros and cons, right? So they have stable network identities. They have stable persistent storage, right? It also provides ordered, graceful deployment and scaling, and automated rolling updates as well, right? But on the other hand, because each of these kind of stateful applications like MySQL or Postgres or Dragonfly, like they're different, or they have different requirements when being managed, right? Like maybe maybe Dragonfly needs to take a snapshot before exit, stuff like that, right? So they are different. That's why for each of the applications, an operator needs to be developed, right? So it's not universal. So we need to devote effort into developing an operator for like different stateful applications, right? So good news is that Dragonfly already has a Kubernetes operator. It is released GA back in last year, November, right? So yeah, that's if I remember correctly, that's right before the KubeCon in the States last year. This year, by the way, we're gonna be at KubeCon Paris and probably States as well. So yeah, in March, we're gonna be in Paris. So if you happen to be there, or you are going to, please stop by our booth, and we can have like more conversations and stuff. And yeah, in January this year, we have the operator version 1.1 released. So yeah, we have always have continuous improvements and efforts put into the Dragonfly Kubernetes operator. So the operator itself, it makes it much easier to manage Dragonfly instances for your DevOps team using Kubernetes, right? So we have a few very important features that's being covered by the operator. The first one would be like we have custom configuration options, right? So you can configure directly with the operator, and as well as passing, Dragonfly also has a bunch of server flags itself, right? So you can also pass those server flags via the operator. We also have like automatic failover, kinds of like you don't have to manually intervene when like there's a primary to replica failover. So that's also handled. You can also use the Dragonfly operator to scale your Dragonfly deployment instances horizontally and vertically, up and down with the custom rollout strategy. Security is also an important feature. Sometimes we don't pay attention to that on day one, but it will come up later on during your deployment, during your development, right? So yeah, we have password and TLS based authentication built into the Dragonfly operator as well. On the snapshot side, it's another important aspect because it's good practice to take snapshots. So we support doing that via persistent volume claims. It's a standard Kubernetes term, as well as to cloud storages like S3 or S3 compatible cloud storages. And last but not least, monitoring is also important. So yeah, with the Dragonfly operator, you can utilize Prometheus and Grafana for monitoring very easily as well. All these features I mentioned, they are updated in our documentation pages over here, like under managing Dragonfly operator. So if I head there like very briefly, yeah, so this is our docs page under managing Dragonfly operator. You're able to find individual sections for the features that we talk about. Cool. So for instance, let's take one example. So this is a screenshot from the configuration page. Yeah, it's identical here. As you can see, you will be able to pass like Kubernetes specific configurations, like how many replicas you want in here, right? In the meantime, as I mentioned earlier, if you want to pass some server flags to Dragonfly server itself, you're able to use the args argument, and it takes like an array of string where you can specify whatever Dragonfly server flags that you need. And yeah, and we have many more down here as well. So that's one example. And yeah, as for high availability, failover, scalability, I think that's one of the most important topics when we talk about in-memory data store and how to manage them, right? So yeah, with the Dragonfly operator, it's very easy to set up a topology like this, where the operator is kind of like the overall cluster manager, and in this setup, we're gonna have one Dragonfly primary, which is the main instance, handling both reads and writes commands, right? And alongside we have two replica instances that's being replicating the data, the writes from the primary, and they can also offload some of the read commands from the primary. So yeah, with the operator, it's easy to do such a thing, and we're gonna show that in the demo soon. Cool. I think that's about it in terms of the slides. Laura, before I jump into the actual demo, do you see any questions so far?
Is the Kubernetes operator open source?
Oh, right. That's a good question. Yeah, maybe I have I didn't make it super clear, but yes, let's see. Right, public. Yeah, as you can see, this is a public repository under our Dragonfly DB org. And yeah, it is open source. And as I mentioned, we just reached a new version 2 weeks ago. And yeah, you can use this freely however you want to help managing your Dragonfly setup. Yeah, whatever I'm about to show today, you have all those features from this repo for sure. Good question,
Thanks,
by
Joe.
the way. I think I didn't. Sorry about that, I didn't mention, but yes, it's open source. Cool. All right, let's see if there are more.
Yes, we have a question from Will. So question for after the demo. Okay, we'll wait to the demo. So are there any plans for community side to release a forums page? We will deal with these questions after the demo, but thank you, Will. I'll keep them coming, folks. But over to you, Joe, to demo first.
That's great. Sounds good. So for today's demo, yeah, we have a bunch of features over here. Today we're gonna demo two of them, which are snapshots, taking snapshots to PVC, and the second one will be the custom rollout strategy, right? So yeah, I will now demonstrate how easy it is to deploy and manage Dragonfly using the operator. And what I like about Kubernetes myself is that my background before joining Dragonfly, I'm more of an application developer, so I focus on those application business logics more than the infra side of things, right? But yeah, really, what I'm really love about Kubernetes and our documentation pages is that you basically can just follow along, and it doesn't take too much to try it. For prod, maybe you need more information, you need more training, discussion with your team. But as for as for getting started with Dragonfly using the operator, it's so easy, right? So basically, let's see what we have right now. So I believe I have this Minikube cluster on my local machine. Like it's easier for demoing, right? So it's less likely to go wrong. So yeah, it's running, and I believe it's fresh. So there's nothing in there. And I'm gonna be using two terminals. So yeah, I will be jumping like between them, but I will try to make them clear. So for now, let's see. Git control get all. I shouldn't have anything except for the Kubernetes cluster itself, right? So what I can do, as I said, basically, is just follow along. So the first step, we need to install the Dragonfly Kubernetes Operator, which is kind of like extends the Kubernetes cluster so that it knows how to deal with Dragonfly. Yeah. So basically, it's using the code from here, right? So let me just straight up grab the command over here, and I'm gonna run the command. And as you can see, we have the corresponding resources created over here. So now the Kubernetes cluster itself is it's a little bit stronger. It knows how to deal with Dragonfly now. Cool. So the next thing, what I'm gonna do is to, head to the PVC page over here, right? So I'm gonna just grab this command and we're gonna take a look before we run it, right? So let's clear this. So yeah, so basically this is telling Kubernetes or the operator that we want to have a Dragonfly set up, right? So the name would be Dragonfly PVC. And for this PVC demo, we need only one replica. By the way, this replica is the Kubernetes replica, right? So it basically means how many instances you want for Dragonfly. So with one Dragonfly instance, it's one replica, but that instance in the Dragonfly world is a primary, right? So itself is not a Dragonfly replica, it's a Dragonfly primary or Dragonfly master, which handles both reads and write. And this snapshot configuration is quite magical, right? So underneath we have two more configurations or options. The first one is a cron schedule, right? And this basically tells like Dragonfly or the operator how frequently we want to take snapshots automatically, right? So in this case, we're having like a 5 minute, every 5 minutes. It's actually every 5th minute, I believe. So yeah, basically that's the gist. And here, the persistent volume claim, PVC, this is a standard configuration in Kubernetes, and we are following the exact syntax as well, right? So yeah, you can, if you're interested, you can read more about the PVCs. I believe we have links to there, but yeah, it's standard stuff. So we don't invent anything. We just follow the spec, but we developed the operator, accordingly based on the existing syntax to support it, right? So that's that, and let's see if I have something else. Right, that's on the right hand side. Maybe just try to do that pod thing again. S cube extra T. Yeah, so we don't have any pods at the moment. Okay, so on the left hand side, I'm gonna let the operator to start this Dragonfly instance with this PVC, specifications or snapshot specifications for us. Right, so once I have that, let's see. Yeah, we have one pod created for this PVC demo. Yeah, let's just give it some time so that it is ready. Right, in the meantime, let's see. Yeah, maybe we don't have questions at the moment. We'll probably continue and answer questions later. Cool, it seems that the pod is ready right now, right? So what I'm going to do on the left-hand side is that I'm going to run another command. So this command is quite long, but in the end of the day, it's starting a temporary instance that's running ready CLI within the cluster, right? So that we have a client to talk to this Dragonfly instance. So then you run that now. And on the right-hand side, what we can do, we can first check that our instance is indeed matches whatever we configure, right? So yeah, this is the instance or the pod we just created. As you can see, we have the cron schedule, we have the PVC spec, and then I'm gonna just shell into that pod so that I can find files in there, right? So in here, I'm currently in that Dragonfly PVC pod running like shell, and if I go up a little bit and then cd into the Dragonfly folder, there is a snapshots folder, cd into snapshots as well. Let's see, yeah, currently we don't have anything. So yeah, we specified this, but we are using the default path, right, for this PVC. So the snapshots would be taken in here, right? So yeah, that's the preparation that we need. So remember, on the right hand side, I'm kind of in the pod, and I'm at the location where the snapshots are supposed to be taken. So on the left hand side, let's see if the ready COI instance is ready. Yeah, there we go. So this is a ready COI temporary instance, also within the cluster, and it's talking to that Dragonfly PVC Dragonfly instance, right? So at the moment, I should see nothing. I have no keys in here. Let's do a debug populate. Let's say 10 keys. And now we have like 10 keys, right? That's being saved in this Dragonfly PVC instance, right? So on the right-hand side, we do have a dump here already, but if you look at the time, it was taken exactly at 30. So it was triggered by the cron job that we have, right? It takes snapshots every 5 minutes. So in here, I'm gonna take a manual snapshot using the save command. Right? If I do that, as you can see, we have a new batch of like snapshots taking, just now, right? Close to the 31 minutes, right? So these are the snapshots I just took. Cool. So yeah, that's basically it. If we specify a snapshot configuration, and underneath that we use a PVC spec, we're able to store snapshots to the desired places, right? So let's try something else. Let me exit from the pod, and let me do the watch pod commands, right? So yeah, as you can see, we have this Dragonfly PVC instance running. We have this temporary ready COI instance also running, right? So I'm also gonna exit out of the ready COI instance. So the COI is gone, right? So the COI is gone. So what I'm gonna do is, what if I, delete the pod, right? So let's do kube control delete pod, and I'm gonna delete this pod. So deleting a pod in Kubernetes, it doesn't, it deletes the pod, but it doesn't delete the service or the deployment. So Kubernetes will automatically replace this pod, right? So let's see what happens. So deleting the pod, see pod gone, then creating again, and it's trying to get ready, right? In the meantime, then you run this Redis COI command again, so that we have a way to talk to the instance. Yeah, let's give it a few seconds so that it is ready again. So yeah, to recap a little bit, what I just did, I deleted the pod, and then Kubernetes automatically replaced the pod, right? So, and now it's ready. So, and now here, I will try to use this temporary Redis COI to talk to the pod again. Yeah, so basically what I want to verify is basically just that the keys are still there, right? Because of our configuration, right? This instance or pod, it knows where to store, to the PVC in terms of taking snapshots, right? Upon restart, because it's in-memory store, right? The memory is clear, but upon restart, it knows where to load the snapshot from the PVC as well, right? That's why after the whole, deleting, restarting process, we still have the keys in memory over here. Cool, that's about it. That's, that's the demo for PVC. Let's see if we have questions over here.
I have one question sent in from Ash Joe. His question is it good practice to do a snapshot to PVC, or is it necessity? Do you always have to do it?
Right. Yeah, that's a very good question. I think it's a more broader. It's a broader question in terms of how you want to manage your in-memory store, right? So, personally, I think it's a good practice to take snapshots. It's just like a matter of where you want to store it, right? So now we support PVC. You can also take snapshots to cloud storage like S3, right? If you're running Dragonfly on your server bare metal, you can also take snapshots there as well. So it will be saved on your machine, on your disk directly, right? So overall, I think it's a good practice to take snapshots, but also depending on your use cases, right? So I would say sometimes if you're using Dragonfly purely for caching and you can tolerate lose data, start fresh in memory, all the data is already still in your database, right? You just need to you just need to reboot or rebuild your cache gradually. That's fine as well if you don't have to, if you don't care about snapshots. But overall, I would say it's a good practice. It's just now we have different methods for you to take snapshots to different places, right? So yeah. Cool.
Thanks, Joe. And if anybody else has any other questions, feel free just to pop them into the Q&A and we can get to them as they come through. So thanks, Ash, for asking. Back to Joe.
That's great. Cool. So now we're done with the PVC demo. Let me clear the custom resource for that configuration, right? So if I run that, if you're familiar with Kubernetes, it's not deleting, say, deployments. It's deleting resource that's being managed by the CRD, right? So yeah, now we have no pods over here. Cool. Next up, start fresh. We're gonna do a rollout strategy. I'm gonna take a similar but different configuration over here. And before we run that, let's also take a look. So let's take this configuration, right? So it's a little bit longer, but overall, we're kind of using default stuff with some labels. And this time the name is gonna be Dragonfly sample, right? And we're gonna have 3 replicas, and we're gonna have specific resource requirement for each instances as well. Again, I kind of want to emphasize that this replicas is for Kubernetes. So 3 replicas for Kubernetes means 3 instances, right? But on the Dragonfly world, 3 instances in this setup is gonna be 1 primary, 1 Dragonfly primary, and 2 Dragonfly replicas, right? So when I do this, it will be something look like this, as we saw before, right? So the operator is managing them, and we specified 3 replicas or 3 instances to Kubernetes, right? In the Dragonfly world, if you have 3 instances, we guess or not guess, we think that what you mean is 1 primary and 1 Dragonfly primary or 1 Dragonfly primary or master, and 2 Dragonfly replicas. Otherwise, it doesn't make sense, right? If it's all Dragonfly replicas, then there's no primary and there's nothing taking the write command. It doesn't quite make a lot of sense. I hope that's clear. Okay. Without further ado, let's see the magic. Let's try to do that. So as you can see, after I specified this configuration, the operator starts working, and it will first try to create the sample 0, which in this case, I believe it's going to be the Dragonfly primary or Dragonfly master, right? Because it's the first instance, right? Then it's ready, and the operator tries to do the second instance, right? Dragonfly sample 1. In this case, it's going to be a replica, right? So it's going to be one of this. So sample 0 is this, and sample 1 is this, and maybe sample 2 is this. So yeah, just to give you more visual. Okay, sample 1 is ready as well, and then sample 2, right? And yeah, this is basically how easy it is to set up like a high availability topology using the operator, right? And you know, I don't understand everything for Kubernetes, but you know, you gradually check out the different specs, configurations, and you know more. And you know, it's not hard, at least, to deploy locally, right? For prod, maybe you need more, you know, caution and you know, help with your teammates. But you know, for me, just trying this out, it's so easy. Cool. Now we have all 3 instances ready, right? So what I want to do is that let's confirm which one is the Dragonfly primary or the Dragonfly master, right? So yeah, as we have guessed, since sample 0 was the first one to be created, so it is the master or the Dragonfly master or the Dragonfly primary and replica. And similarly, sample 1 and sample 2, they are replicas of sample 0. So again, we have this, right? So these 2 are replicating from the primary. Cool. So that's awesome. So what I want to try now is, what if I want more, you know, resource request for all the instances, right? So I'm going to copy another configuration over here, and before we run it, we take a look. So it's the same thing as the first configuration, except that I'm asking for more, you know, CPU time and memory, right? So it's kind of like scaling vertically for all of these instances, right? And let's see what will happen if I apply this configuration. So it's configured, and again, the operator starts to work. As you can see, it stops and recreated sample 2 first, not sample 0, right? What's the logic behind this, right? Because sample 2 is a replica, is a Dragonfly replica, right? So if you're asking like a resource change, no matter you're scaling down or scaling up, right? What's the logical step, right? The logical step would be to start with the replicas, right? Because otherwise, like, you know, if you start with the Dragonfly primary, then you know, like you're not gonna have like a, like, how would you handle, you know, continuous read and write? We start with replicas, and when replicas are ready, right, by the time we need to recreate the primary, we already have 2 replicas that are ready with the new spec. And those are good candidates that to fall back, to fill over, right? That's why we start with the replica, because after they are recreated and, you know, restarted, they are already with this new resource request spec, and they're ready as like good candidate for failover. And then finally, the operator replaces the old Dragonfly master, which was sample 0, right? Then either sample 1 or sample 2, because they are ready, they have the data, they also have the new resource spec, right? One of them is going to be promoted as the primary. Let's check if that's the case. So here, as you can see, Dragonfly sample 0 now is the new Dragonfly master or the Dragonfly primary, right? And then 0 and 2, they became the replica, right? So this makes sense, right? Because this is like a correct or logical step, and it's built in to the operator. So when you do this vertical scaling based on resources, right, it's handled smoothly. Cool, I find that amazing, but let's continue. I'm gonna copy yet another config over here, right? And again, it's the same thing as the second step. So the CPU time and memory, like they're 500, but this time we want 5 instances in the Kubernetes cluster, right? So it's going to be 1 Dragonfly master and 4 Dragonfly replicas, right? So, but with the same hardware configuration. Let's see what happens, right? It just went straight up, creating the, the fourth instance and the fifth. Let's give it a minute.
So just in that minute there, Joe, we just have a question there from Eric. So Eric is asking, are there any limitations to the number of replicas that the Dragonfly operator can replicate or create?
Right, so the number of replicas, right? So yeah, no matter if you're using the Kubernetes operator or not, theoretically there is no, right? But it doesn't, but to me, it doesn't quite make a lot of sense if there are too many replicas, right? So theoretically, no, but how many replicas you can have is constrained by a couple of things. For instance, like how large is your machine, or how large is your Kubernetes cluster, right? Because the hardware resources are limited. So yeah, so that's limited by that. On the other hand, imagine you have like one Dragonfly primary and say 1,000 Dragonfly replicas, right? Then that primary instance is going to be so busy replicating data to those 1,000 replica instances, right? And like you probably don't get too much benefits out of that 1,000 replicas handling only like read commands for you, right? So yeah, so to answer your question, theoretically no, like hardware limited, and also maybe bandwidth limited, right? Also 1,000 is kind of extreme for high availability.
Just a
right?
bit,
So
yeah.
normally,
So it's kind of like just using common sense and best practices. Cool. All right. Thanks, Joe. Appreciate
exactly. So no problem. Normally, I would say 3 to 5. That is like a reasonable range, right? Cool. So what happened here is that we used a similar configuration, except we only changed replicas from 3 to 5. So as you can see, no old instances were restarted, right? There's still this old one, like from step 2, right? But we have, why? Because we don't change any other spec. We just want more replicas, right? So these 3 are the old ones from step 2, and these 2 are the new ones from this step, right? And if we run these 2 commands again, you can see, because there's no hardware or resource or other configuration change, right? So there's no need to replace our master, which was sample 1 over here, right? So there's no need to do that. So it's kept, it's not restarted, right? And then for the replicas, now we have 4 of them, right? 0, 2, 3, 4. So no matter if you're scaling like vertically based on the resource requests, or if you're scaling like horizontally, by having like more replicas, like the operator takes logically correct steps one by one step at a time, to establish the eventual setup that you would desire, right? And then the final step I want to try is, what if I go back to our original setup, right? Which is the step 1 setup, where we have 3 replicas, and the CPU and memory resource requests are also like down from like 500 to 200. So this is like our original setup, right? Let's try that. So again, the operator should take logical steps, right? It first removes 2 of the replicas because you specified 3 over here, right? Then, because the hardware, like the resource requests, they're changed as well, right? So let's just give it some time. The operator should, again, take logically correct steps. It will start with the replicas, the Dragonfly replicas, and then eventually, the Dragonfly master. Remember that at the moment, the Dragonfly master is still Dragonfly sample 1, right? But after the operator has finished the job, it will be another instance, because this Dragonfly master instance will be replaced the last, and before that it will be filled over to replica that is ready, right? So it takes a bit for the Dragonfly control loop to do this thing, right? So we're basically waiting for it to perform the act, right? Cool. Let's see. yeah, while it's running, let's see if we have more questions so far.
No questions right now, Joe. I know we're just coming close to the time of the end of the session as well, so I think we should just keep moving on.
Cool. All right. That's okay. Let's watch together. Yeah. See, it started. So remember, sample one is at the moment still the Dragonfly master. So the operator start with a replica, which is sample zero, right? So it's being terminated and recreated with this new resource specs, right? So this is like the youngest and with the new spec, and at the moment it is a replica. Then start with sample two, similar deal. Sample two was a replica. It's being destroyed and replaced with this new resource spec. And the operator is monitoring it. It's doing health check until it is ready. And it's ready. And finally, sample one, which was the old Dragonfly master, right? So it's been terminated. Before termination, either sample zero or sample two are promoted as the new Dragonfly master because either of them they have the the new resource spec, right? So sample one is no longer the Dragonfly master anymore. Let's just double check that. As you can see, right? So this time the operator picked sample two as the master, the Dragonfly master, right? And then sample one and sample zero, they are Dragonfly replica, right? So yeah, like this is how flexible and powerful it is to use, Dragonfly operator to scale up and down your instances, and it will take logically correct steps to perform them one by one. So you have like the best availability and everything. Cool. That's the demo for today. We have covered this too, but yeah, definitely feel free. I really want to cover like a monitoring one, maybe next time. And guys, please sign up for the next session as well. We're probably going to cover the monitoring. It's more visual, but this time we covered these two basic, I would say less visual ones, but still impressive, I hope. Cool. So yeah, Dragonfly, that's Dragonfly as a community-driven open source project, I think it's amazing. Dragonfly, the company, we are like building Dragonfly Cloud, right? So why is that? You now have the operator, you now have the core, you kind of have everything, but why, right? So Kubernetes and container environments, they still have like abstraction layers, right, on top of the bare metal hardware, right? So I'm sorry that I don't have the benchmark on the same machine, but you can probably take a look at these two, right? We have 4 million on C6GN. It's 16x though. We have 1.3 million on the 8x, right? So if we double this 8x to 16, we're still not this number. If we assume that it scales perfectly linearly, right? It still doesn't match 4. So we have to take some penalties because of the abstraction layers, right? So that's basically why. We spend effort to develop Dragonfly Cloud, because we want your Dragonfly instances running on bare metal, but you still have all the Kubernetes operator conveniences and monitoring capabilities, and everything. That's why. So if you're interested, currently we are onboarding customers on trial basis. But if you're interested or you want to talk with us, just to check the possibilities and whatever, and get engaged and have a chat, yeah, please fill out this form. It's located at dragonflydb.io/cloud. And other than that, that's it for today's presentation and demo. And let's see if we have questions.
Thanks, Joe. That's really, really useful. Thank you. And again, don't forget, if you have questions on the cloud, do head on over to the site, as Joe mentioned, fill in the form, and we can also get back to you straight away on that. The question we do have to wrap up the day is from Will, who's just unfortunately had to miss the last few minutes, but he had a good question and I want to answer it, which is, are there any plans on the community side to release a forums page? When they set up their Dragonfly instance previously, they did use Discord to get their questions. They found the search kind of mechanism not as good as other forums. That's a really good question, Will, and actually something myself and Joe are tackling this week. So hopefully by this time next month, when we have our next set of office hours, that'll be March 13th. Don't forget, it's the second Wednesday of every month. We will have some good news, and hopefully that'll be our next community update, is to have our own community forum on there. We're always constantly looking for feedback, either like message us on Discord or drop myself and Joe an email. We're happy to take back any form of feedback. We're constantly looking to improve things. As you can see with our latest new programs, I mentioned the community writing program, our quill program, and also our Dragonfly ASCII challenge. So I'm really looking forward to seeing those applications coming in over the next couple of weeks. Thank you to Joe today for hosting a great demo. Thank you to all the people who asked all the questions. And if you missed out, don't forget, we're going to send this to you and you can rewatch it at your own time. Thank you all again, and I will see you all next month. Take care, folks. Have a great day. Bye-bye.
Take care. Bye.